A vertical and a horizontal shift is like when you take a graph and you move it up, down, left, or right. We're not changing the shape. So if you know the shape of a parabola, what it normally looks like, and you're just shifting it left, right, up, or down, you're keeping that same shape. You're just sliding it. Sure. It's a good pencil, isn't it? Some people make fun of them and call them grandma pencils because they say every grandma uses those pencils, but my grandma doesn't. She does? That's what someone else said. They're like, these are grandma pencils. I think my grandma uses pen. Vertical shift. Going up, if you have a function and a number added to the outside, that means that graph's going to move up so many units. So an example of that, I'm just going to say h of x equals x squared plus 4. That means the normal parabola that starts at 0, 0, this plus 4 means it's just going to move up 4. The shape's going to stay the same. So if you know that shape, you don't have to really make an XY chart to graph it. Like, it's just a really quick graph to make. And if up means you add a number, I hope it makes sense that if we're shifting down so many units, we're just going to subtract that. Remember doing this last year with the H and the K? We talked about H and K a lot last year. No? Every graph we learned, like we had that same slide again that had plus K and then up, minus K and then down. So I could say the square root of x minus 2. My normal square root graph is that half of a parabola starts at 0, 0. All this means is I'm going to shift that down 2. So instead of starting at 0, 0, I'm going to start at 0, negative 2. Everything else stays exactly the same. Part of your homework today is going to just be telling me what the shift is, like just by saying, that means it goes up 4. That means it goes down 2. And also graphing them. Vertical makes sense. Up is positive, down is negative. Horizontal, it's backwards. It's the opposite of what you probably would think. Right? Horizontal is moving right or left. And if you're moving right, you actually subtract that C value from the inside. Actually, I'll just show you both of these at the same time, because it's really the exact same thing, except for right, you're going to take the function minus that C value. Left is plus. Also notice the difference between vertical shifts and horizontal shifts. Vertical shift, the number's on the outside of the function. A horizontal shift, the number's going to be added or subtracted in the function itself. And again, I just always remember it's the opposite of what you think. You would think that a minus C would mean you're going back on the graph, but that actually means you're going to the right. An example of that would be like the absolute value of x minus 1. Because the minus 1 is in the absolute value bars, that tells me that that V-shaped graph is going to shift to the right 1 unit. And I could say x plus 4 to the 3rd power. Again, notice the plus 4 is inside that function. So normally, that's that nice little S graph. If I add 4, it's actually going to go to the left 4. Yes? That's a lot to FOIL out. And then make an XY chart. Totally not. That's why you should know this. Last year I didn't stress this a lot, like we talked about it a lot, and I always said it makes life a lot easier, but I never said like you had to graph that way. I said you could always make an XY chart. You can still make an XY chart, but you're definitely going to have problems that ask you to explain the transformation, like what's happening in this graph. So either you're going to be able to make an XY chart and then explain where it's moved, or you need to know these rules. So it is important things to know. It makes graphing so much easier.
But on the test, it says explain the transformation. You could do an XY chart, find it, graph it, and say where it is.
It's going to take you like 4 times as long as someone else, as long as you get your whole test done in time, right? That's the whole thing. Time management. Vertical horizontal shifts, not so bad to do. So let's look at a few of these. Again, look at I really am upset that my smartboard changes my spacing every time.
Is this all that's on the homework though?
No,
Well, the titles, this is
there's more than just vertical and horizontal shifts. There's also stretches and shrinks, and there's also reflections, right? There's still more types of transformations. But Logan's right. You can just make an XY chart to graph these. But I want to show you that if you know what that basic graph looks like, and that's why I stress that you know those 10 basic functions, you're going to be able to do the graph of this a lot simpler. I'm going to graph both of them on this. On your homework, you don't have to unless it says graph both x squared and x squared minus 3. But I want to show you how this shift is happening, and I want to show you how you can graph these really quickly. So I'm going to graph the original one in black here, and then we'll graph the transformation. The function y equals x squared should be a function that's really quick for you to graph. You should know it's a quadratic, you should know it's a parabola, and you should know that it starts at 0, 0. And if you plug in 1, you get 1. If you plug in -1, you get 1. If you plug in 2, you get 4. And -2, you get 4. Right? That is f of x equals x squared. The idea is that when you are subtracting 3, first of all, what's the transformation that's happening on this one? If I said describe the transformation for g of x equals x squared minus 3, how is this one going to look different than this one? It's just going to move down 3, which means the idea is I'm taking this graph, and I think since this is a smartboard, I actually could do this. I'm taking this graph, and I'm shifting the whole thing down 3. Oh, that's not good. I'll just move it back down. But I'm just sliding it down 3. So instead of starting at 0, 0, I'm going to go down 1, 2, 3. And I'm going to start at 0, -3. And you actually could shift every single point down, but I never do. Like, I know the shape of it. I know when I go over 1, I'm going to go up 1, because I think about those 2 points right there. And I know for x squared, if I go over 2, how many do I normally go up? Up 4, and it's the same. Over 2, up 1, 2, 3, 4. And I'm going to get that exact same graph without a whole lot of effort. And on your homework, you wouldn't have to graph the original one also, unless you just wanted to. Make sure your graphs are accurate. I was grading some of the worksheets, and it wasn't terrible on some of them. But you definitely make sure that you pick enough points that you're making an accurate graph. Don't just graph 1 point and then sketch a parabola and think I'm going to count that right. I expect that you have a few points on there and that it's in the right spot. I also want to talk about domain and range on this for a minute. The domain and range of a parabola, like the normal f of x, the domain is all real numbers, and the range, it starts at 0 and goes to infinity because it's going up. If you know what the transformation's doing and you know what the normal domain and range is, it makes domain and range also a little bit easier. If I'm just taking this graph and I'm shifting it down, is it going to change my domain? No, it's not going to change. So my domain is still all real numbers. But if I'm taking that graph and I'm moving it down, is it going to change my range? What's my range going to change to now for the g of x? It's going to now start at -3 and go to infinity. I could tell that from this because I know that the smallest I'm ever going to get out of that is a -3 because that's out there. That vertical shift is always where your range is going to start on a parabola. What about this one? H of x equals x plus 2 squared plus 1. I think it's a smart place to start after you make your little sketch of your graph, is think about what the transformation is going to be. And for me, I always want to know where's that vertex And then from there, I can make my graph without having to pick a bunch of points. So what does this +1 mean on the outside is going to happen? It's going to go up 1. And what does this +2 on the inside mean? It's going to go left 2. Which means my normal x squared that starts at 0, 0, I'm going to move it up 1 and left 2. So instead of starting at 0, 0, I'm going to start up 1 and left 2. Does that make sense to everyone of how I know it's starting back there? Or you could go left 2 and up 1. You're still going to get that same starting point. If you can find that vertex, you can make an XY chart if you want. But if you know that shape, when I go to the right one from x squared, what do I normally do? When I go right 1, I go up 1. And when I go left 1 from the vertex, I also go up 1. Right? It's always going to be that same shape if I'm just sliding it around. And from that vertex, if I go right or left 2, how many do I normally go up? 1, 2, 3, 4. If I go left 2, I go 1, 2, 3, 4. And that's going to give me enough points that I can make a pretty accurate graph there. That's a lot quicker than making an XY chart. Again, you argue with me no matter what. What's my domain on this one going to be? Yeah, I've moved back to the left, but this is still a continuous graph. This side is going to go this way forever. This side is going to go this way. Every x value can be plugged in there. Your domain is going to always be all real numbers on a quadratic equation. What's my range changing to on this one? Yeah, this right here. It's going to tell you every time, whatever it's moving up or down. Now my lowest value is 1 going to infinity. You can do this with any of those 10 graphs. Absolute value definitely shows up a lot for doing this. What shape is an absolute value graph? That's a square root. A V-shaped graph. You should probably study those. 10 function. You should know. But you don't get your notes on your test. I do know that. Another type of transformation is a reflection. And a reflection can be over the x-axis or over the y-axis. If the negative is out in front of the function, so h of x equals negative f of x, that is going to give you a reflection in the x-axis. And so the way that I think about it when I try to remember which way it is if the negative's out front, all the x values are going to stay the same. I can still plug in everything I want for x, but whatever I would normally get, I'm now going to get the opposite. So all your y values are changing. So when you see a negative sign out front, that means it's going to flip over the x-axis. And so I gave you a little example here of absolute value.
So if that happens, it's looking for x.
Yes, and I'm going to make a little graph here for you. We'll call this the, I'll just leave it. Y equals the absolute value of x. Starts at 0, 0, and it's just over 1, up 1, over 2, up 2. It's going to look like this. Because absolute value is always positive. But if you throw a negative sign outside of that function, no matter what you plug in now, it's always positive, but then you're going to multiply by a negative. So you're always now, if you graph this one, if you plug in 1, you're going to get negative 1. If you plug in 2, you're going to get negative 2, because all the y values are going to change. And so again, XY chart works if you want to just make an XY chart, but if you can remember this, it definitely makes things a lot easier. There is one where you flip over the y-axis. And that would be if you put the negative inside the function. So it's, again, all about whether it's inside the function or outside the function, just like with vertical and horizontal. value graph and I flip over the y-axis, is my graph going to look any different? Because it's already symmetric. Like if I flip that around, it's still the exact same thing. Same thing with the parabola, just y equals x squared. If you just flip y equals x squared over the y-axis, again, it's the exact same graph, so you don't always get something to look different on some of those. But I picked a square root one for you. Should totally be a longer line, but there we go. Y equals the square root of x plus 2. The plus 2 is not under the square root. I don't know why. I could have just done this without the plus 2, but that's okay. And y equals negative, the square root of negative x plus 2. What? I probably should graph this first so you can see what it looks like, right? What's the square root graph look like? Half of a parabola normally starts at 0, 0. I kind of threw in an extra thing here. What if I add 2 on the outside of the square root? What's this one going to do? It's going to go up 2. So instead of starting at 0, 0, it's going to start up there at 2. I'm not going to pick a lot of points here, but it's going to start, oh, I'll use green since I underlined it green. It's going to start up here at 2. If you plug 0 in, you just get 2. If you plug 1 in there, you're going to get 1 plus 2, which is 3. You don't need a whole lot of points because you should know it's just going to be half of a parabola. If you plug 4 in there, you get 2 plus 2, which is 4. And you get that lovely half of a parabola. When you throw a negative under there, you can no longer, especially in the square root, you can't pick the same x values. I can still pick 0 because you don't have a negative 0. But what happens if I pick 1 for x? Yeah, I get I can't graph I. And so your domain is changing when you put a negative underneath that square root. What numbers could I pick so that I could actually get a real number out of this? Could I pick negative numbers? Because if I pick a negative of a negative number, is that going to turn into a positive number? So basically, I can pick the exact same points that I had, only now they're negative. That's why it's flipping over. So when I plug in 0, I still get 2. But now you have to pick like negative 1 and negative 4, because otherwise it would be an imaginary number. So that's what's happening. So when you pick negative 1, you still get the same y value. You still get 3. When you pick negative 4, you still get 2 plus 2, which is 4, and it just flips over the y-axis. So negative inside flips over the y-axis, negative outside flips over the x-axis. On your homework, it's going to kind of be all mixed up. Like there might be horizontal, vertical, and a reflection all in the same graph. So let's see what we have next. Next we have examples or more stuff. We have one more type of transformation. Okay, here we go. The last type of transformation I think is the hardest one to keep track of and the hardest one to graph on your own because it does actually change the shape of it. If you're just shifting it or flipping it over the axis, you're not actually changing the shape. So we call those rigid transformations because you're just basically like picking up the shape and moving it around. But we also can stretch or shrink that graph. And we call those non-rigid transformations. Those do change the shape of our graph. And if you think back to those step functions that we did, sometimes it made the step shorter, sometimes it made the step longer. And when you multiply by a number, that's going to stretch or shrink your graph. These are ones that it's definitely nice to know, and there's definitely some shortcuts. But these are ones that I would probably recommend, get an idea of where to start and maybe pick a couple points on an XY chart just to make sure what's happening. These are kind of confusing rules here with this. I kind of worry more that you know about whether it's vertical or horizontal, then you know all these. I'll show you all this. I'll show what I'm talking about here. We'll talk about this. So again, a vertical, just like a vertical shift is when you add or subtract outside. A vertical stretch or a vertical shrink is going to be when you multiply a number on the outside of the function. Whether you know whether it stretches or shrinks has to do whether the number is bigger than 1 or a fraction between 0 and 1. And so those are the parts that I don't care a lot about if you know this part. But I do want you to know that a number multiplied on the outside is going to change that vertically. An example of this would be like 3 times the absolute value of x. 3 is on the outside of the function. That's going to stretch that V shape by a factor of 3. So it's actually going to make it look a lot skinnier, like a lot sharper V when you do that. And then horizontal stretch, horizontal shrink. And a vertical shrink also on the outside, but the difference is it's less than 1. And I really should say like between 0 and 1, because we're not talking about negative numbers here, right? Remember what a negative does is it reflects your graph. So if you see a negative in front of that, that has nothing to do with a stretch or a shrink. Right. It still would be a stretch by a factor of 2. The negative just means it's flipped over. By less than 1, I mean a fraction. If that number is between 0 and 1, like if I said 1/2 times the absolute value of x, that's going to shrink that graph down by a factor of 1/2. So for this graph that's a V shape, it's actually going to make that V look a lot wider when you graph it. So instead of getting 1 out of that, you're going to get 1/2, and so that's why it's going to shrink that down. Again, this part's not as big of a deal as knowing that outside means vertical is what I want to stress from that. And so if outside means a vertical stretch or a shrink, it should make sense that if the number's multiplied inside the function, that's going to change this horizontally. And notice, I like the way the Algebra 2 book writes this a lot better than I like the way your textbook writes this, but I want to give it to you the way that it is in your book. But they write this as x over c, where c is in the bottom of a fraction already. Make sure that I wrote that right. Stretch where c is greater than 1. Shrink where c is less than 1. But I feel like the horizontal part's a little tricky because the way that they write it, where c is greater than 1, I could write g of x equals x squared over 4. No, just kidding. Sorry. X over 4 squared is what I mean to say. X over 4 squared. Notice how c is already in the bottom. If you pick a number bigger than 1, it kind of looks like a fraction in there. But the big deal that I want to get out of this is that if it's inside the function, it's going to be a horizontal stretch. Or if it's less than 1, think about if you plug 1/2 in here for c. We just talked about dividing by fractions. If you plugged in x divided by 1/2, that's really x times 2. That would be like saying 2x squared. So again, I feel like those rules can be a little bit confusing, but no, outside means vertical, stretch or shrink, and inside means horizontal. And that's all I'll be really looking for when they ask you to describe the transformation. I want to graph a couple of these with transformations just to kind of show you how you can use this to help you graph, but XY charts aren't the worst thing in the world to do every now and again either. So let's do some absolute value. There you go, everyone done writing this? Oh, I think I want to make this. Again, I'm going to draw both graphs, the original graph, and then the one that we're stretching or shrinking. Just because I like for you to see the difference here. You don't have to do that. But the absolute value of x starts at 0, go over 1, up 1, over 2, up 2, back 1, up 1, back 2. When I multiply a 2 on the outside, that means I'm going to be changing that graph vertically. I'm going to be stretching it or shrinking it. I think bigger than 1, I'm actually stretching this one. Which means instead of doing just over 1, up 1, you're multiplying all of those by 2. Doesn't take that much to actually pick a couple points if you wanted to. When you plug 0 in, it doesn't change. It's still 0. Normally when you plug 1 in, you just get 1. But because we're multiplying by a factor of 2, we're going to double that. Like every number we normally get, we're going to double. Just like with the parabola, you know the normal shape. You can do this without making XY chart. Normally, I go over 1, up 1. Since I'm multiplying by 2, I'm going to go over 1, up 2. Normally, I go over 2, up 2. But since I'm multiplying by 2 and I double that, what am I actually going to go up? 4. Just doubling. So XY chart does not take very long to do. It's not so bad to do it without an XY chart either. If I go back 1, I'm going to go double that. I'm going to go up 2. Back 2, I'm going to go up to 4. And so you can see that that absolute value shape has been stretched so that the V shape is now, I don't know, sharper, I would say. I totally missed my points there. Has my domain and range changed at all when I'm stretching and shrinking that graph? Still starts from the same point, it still uses all the same values. It's just changing the shape of it. What if I throw this one in? It is going to be reflected because there's a negative and there's a number on the outside. And a number on the outside, which way is that going to reflect? Could be reflected in the x-axis. And because we're multiplying, it's going to be a vertical transformation. Right? I believe less than 1, that's going to be a vertical shrink. Again, making an XY chart, I'm going to do this one kind of locus way. Very quickly. I'm going to pick negative numbers, so I think that's all I really need here. Since it's flipping over. If I plug in 0 here, am I still going to start at 0? I'm just doing this one. Like, we could do this one again if you wanted. This is the normal one. That's the parent graph. If I plug in 1 here, on the normal graph, when I plug in 1, I get 1. But I'm shrinking it by a factor of 1/3, and I'm flipping it over. So what happens when I plug 1 into that problem? It's going to be 1/3 the movement on each one. So I don't really like to graph fractions, so I'm going to pick points that give me not fractions, like 3. If I pick 3, what am I going to get? -1. What else could I pick that wouldn't give me a fraction? 6. Notice what's happening. Normally you go over 1, you go up 1. We had to go over 3 to get that 1. We had to go over 6 to get 2. And it's negative because it's flipped over. So 0, 0, 3, -1, 4, 5, 6, -2. This is where you got to know the shape. Do I need to pick negative numbers too? Do I need to pick -1 and -3 and -6? Or do I already know what they're going to be? You should already know, because it's a V-shaped graph. It's going to be the exact same. When I pick -3, I'm going to get -1. When I pick -6, I'm going to get -2. And notice the difference between a stretch and a shrink. A stretch makes that V shape look a lot skinnier. A shrink shrinks it down, and it makes it a much wider graph. XY chart's not a bad idea when you're doing these, okay? Make your graphs nice when you're doing this. Your homework is the next assignment on an assignment sheet, but if you don't have it, write it down. 1-6. A lot of your homework says support your answers with the grapher. You don't have a grapher. You're the grapher. And actually they say graph by hand, but support with the grapher means check on your graphing calculator.